Hey guys, Mr. Creed here with another video. Last video I posted was on simulations. If you want to know more information about that or to use that to help you fill in your notes, then go check out my YouTube video for that. It is on Canvas as well if you have not, if you do not have access to my YouTube channel. Make sure you like this video, subscribe if you have not already, and let's get started. Okay, so predictions is a way is made based on simulations. Okay, which we talked about in the last video. So probability can be used to make predictions for future occurrences by setting up and solving a proportion. If you're in my class, we do proportions all the time, so this should be no new thing right here. Okay, but we're gonna do it anyways. See if you guys remember this. Okay. All right, so let's look at an example. The probability of rolling a 6 on a number cube is 1 out of 6. If the number cube is rolled 50 times, then approximately how many times will a 6 be rolled? Now, this is an example of a theoretical probability problem. Okay, experimentally, we may not get exactly the amount of times or the accurate amount of times that this 6 should be rolled. Okay, so let's use information. Let's figure out how many times we can roll a 6. Okay, so the probability is 1 out of 6. I'm going to be doing 50 trials. So I'm just going to take the probability, I'm just going to multiply that by the number of trials we are going to create, okay, which is 50. So we got two fractions, all right? We have 1 out of 6 and 50 over 1. So with multiplying fractions, we just multiply across. Okay, so 1 times 50 is 50, and 6 times 1 is 6. So now we're in this spot here where we got to figure out, well, how many times will 50 go into 6? Okay, so to make life easier, I'm going to use my calculator here. So we got 50 divided by 6. Okay, that is going to be 8.33. Repeating. Okay, but listen, it says approximately. So I need to round to the nearest whole number. Okay, so we're going to round this down. We're going to round this down to 8 times. Okay, that's how many times we should expect the 6 to be rolled out of 50 times that we roll this cube. Now, again, that's theoretical. Will it happen if I perform this? If I perform this with experiment? Maybe not. It might hit right on. I don't know. Okay, that's something that we just need to do on our own time, if you like. Okay. All right. So let's do a couple more examples. We got 6 and 7 here. Both of them have two parts to it. Okay. So let's get to it. All right. Kinsey surveyed a group of seventh graders as to whether they prefer video games, sports, or neither. Use the surveyed results to make predictions for the entire seventh grade class with 350 students. Now, survey is always a small scale. Okay, it usually is a way to convey information for a bigger body of people or a bigger body of whatever. Okay, all right. In this case, we got a big body of students, 350 students. All right, so we surveyed 40. So we surveyed 40. How did I get 40? Well, I added 15, 22, and 3 up. Okay, so we got 40 students. So it appears, so let's read A. What is a reasonable prediction for the total number of seventh graders that prefer video games? Well, out of 40 students, 15 prefer video games. Okay, but that's only that's only a part of the student body. Well, if that were to remain proportional of to 350 students, so how many students will that be equal to? Okay, well, I don't know. So I'm gonna write in a proportion here. Now, if you're with me, when you see something like this right here, something should pop in your mind when you what's called butterfly method. Okay, so butterfly method is going to be combining the numbers that are diagonal from each other. Okay, so we got 40 and x, and when you butterfly, you must multiply. So I got 40x or 40 times x, and that is equal to 15 times 350. Okay, so 350 times 15 is going to be equal to 5,250. Okay, so now we're to the point where we have a one-step equation. Okay, so I'm going to get rid of this 40 and keep x on this left side of the equation. Okay, all right. So 40 and x are being multiplied together. To undo that, I'm going to divide by 40 from both sides of the equation. 40 divided by 40 is simplifies to 1, so I'm left with 1x, and that is equal to 5,250 divided by 40. So I'm going to take this answer here, divided by 40, and I get 131.25. Now, can you have part of a person? I don't think so, right? So we're going to have to round this to the nearest whole number. Okay, so that's going to be approximately 131 students. So out of that student body, 131 students are probably going to like playing video games over sports or even neither, okay? All right. B, based on the information in the table, what is the most reasonable prediction of the number of votes for video games in the next 80 votes? Okay. So I'm going to include 80 more votes on top of the 40 that have already been done. Okay. So 15 out of 40 students enjoy playing video games or prefer to play video games. Okay, so I'm going to have another 80 votes in this survey. Okay, so 80 votes on top of 40 is going to be 120 votes. Okay, so I got to figure out how many people are likely to prefer video games over sports or even neither, based on this information already in that table, 15 out of 40. Well, I know that 120 is a multiple of 40, and 120 is 3 times the size of 40. So 40 times 3 is 120. So that would only make sense if I multiply the bottom by 3, I should also multiply the top by 3. 15 times 3 is 45. So a reasonable prediction should be that 45 people or 45 students prefer video games over sports or even neither. Okay, so that would be a reasonable prediction for the next 80 votes. All right. Number 7. When you send mail via the post office, you have an 80% chance that it is delivered to the correct location. Well, my bills get sent by mail, so I hope people better hope my bills come in so that way I make sure they're paid. All right. So you could write this percent as a fraction. So it could look like 80 over 100, or it could look like 8 over 10. Okay, we could use this as to figure out what these for A and B. Okay, so if 430 letters are delivered on Monday, then what is a reasonable prediction for the number of letters that are delivered to the incorrect location? Remember, 80% is delivered to the correct location. That means 20% is not. So 20% or 20 out of 100 will go to the correct location. So 20 out of 100. If I make that equivalent to something over 430, I need to figure out what that something is. Okay, so it's a lot like 6A up here. We're going to use the same method here, butterfly method. Okay, so I'm going to butterfly, and when you butterfly, you must multiply. All right, so we got 100 times x, or 100x, is equal to 430 times 20. 430 times 20. We get 8,600. So 100x is equivalent to 8,600. Okay, I got a one-step equation, so I want to solve that one-step equation using my knowledge. So I'm going to divide both equations to the separate side to two different sides. Okay, 100x is being multiplied together, so I got to get rid of that coefficient 100. 100 divided by 100 is 1, so you're left with 1x, and that is equivalent to 8,600 divided by 100. And we should get 86 there. We'll check that. 8,600 divided by 100. We get 86. So 86 letters are going to go to the incorrect place. Now, that is one way to solve this. You don't have to use this way each time you do this, okay? So I'm going to show you one more way. All right. So if I know that 20% of the 430 get there, okay, 20%, don't get there, 20% of 430, what I could do, I could just take 20% and multiply it by 430. Okay, 20% as a decimal is 0.20, and 430 is just 430. So let's say if we get 86 letters, that's the goal. Okay, so we got 0.20 times 430. Well, what do you know? We get the same thing. So we get 86 as well. So these are the same thing here. So you can do it, but you can do it either way you'd like, whichever one you think is easier or makes the most sense to you. Okay. Now I can say that for the next one, we can't exactly do it this way here. Okay. We're going to have to do it this way here. Okay. All right. B. On Tuesday, it is reported that 500 letters were delivered to the correct location. Based on this information, how many letters were delivered on Tuesday? So we got to figure out how many total letters were delivered. Now keep in mind, 80% are delivered to the correct location. 500 were delivered to the correct location. So 500 is equal to 80%. Okay? 80% percent is usually out of 100%. So I got to figure out the total amount of letters that were delivered to the correct location. So I'm going to rewrite this because I don't have a percent sign on my calculator because I do somewhere. I don't want to take time to find it. So 500 over x is equivalent to the decimal value, so 0.80 over 1.00. Okay, so these are equivalent. 80% as a fraction is 0.80. 100% as a decimal, sorry, 80% as a decimal is 0.80. 100% as a decimal is 1.00. So remember, use the same method we always did that we have been using, butterfly method. And when you butterfly, you must multiply. Okay, 500 times 1 is going to be 500. X times 0.80 is going to be 0.80x. We have a two-step equation. We have a one-step equation. Okay, split your equation into two different sides. These sides must balance. Okay, I don't know if I said that in this one up here, but both sides must balance each other. This side must be equal to 500 and vice versa. Okay, so up here, to get rid of that coefficient, we had to divide. We're going to do the same thing here. Yes, you can divide by a decimal. We're going to divide by the coefficient, 0.80 from both sides. Okay. We're going to be left with x on this side because 0.80 divided by 0.80 is 1. Okay. I will show you that to make sure that you know that 0.8 divided by 0.8 is 1. Okay. So if we got 500 now we got to figure out what is 500 divided by 0.80. Oops. Divided by 0.80. That's 625. Okay, in context of the problem, that means 625 letters were sent out on Tuesday. All right, guys, got any questions? Make sure you comment in the comment section below. Email me if possible, or email your teacher if you're not my student. If you got any questions on this problem, on this section right here. Okay, like this video, hit that subscribe button, and I will see you guys later.